Okay, so today we're going to go over two new topics and maybe review some other concepts. So in Chapter 2, Quadratics, there's a lot of vocabulary. You need to know the different forms: vertex form, standard form, and intercept form. You need to know how to find the vertex in all of those forms. You need to understand the axis of symmetry, maximums and minimums. When is it increasing? When is it decreasing? So there's a lot of vocabulary in this unit. So we're going to go over a few more vocabulary words and then we're going to review a little bit. So here we go. So the first thing we want to do is review finding the y-intercepts. You may already know the y-intercept is where it crosses the y-axis and the x value always has to be 0. Like we should already know that. With the x-intercepts, they're on the x-axis and the y is always 0. So today we're going to focus on the y-intercepts. So to find the y-intercepts, wouldn't we just replace x with 0? And what would that give us? So that'd be negative 2, 0 minus 3 squared plus 1. Do order of operations, do exponents first. And that would come out to be negative 17. So we would say our y-intercept is 0, negative 17. That was where it's going to cross the y-axis. Problem number 2, what is the y-intercept? So wouldn't we just take out the x and plug in 0 in its place? And when we work that out, isn't that going to give us 0 plus 0 minus 3, which is negative 3? Have you ever noticed that when you have standard form, ax squared plus bx plus c, that the y-intercept is always going to be the constant? Have you ever noticed that? Because what happens when you plug in 0 where the x's are? Isn't it always going to come out to be c? I wonder if you've ever noticed that. Number 3 is an intercept form. And if we wanted to find the y-intercept in intercept form, we would just take out the x's and put 0 in its place. And do what's inside the parentheses first. And that's going to be negative 8 times 3. That's negative 24. So our y-intercept is 0, comma, negative 24 would be the y-intercept. Okay, so now we want to look at these other new statements. So this bottom half is super new. So we're going to look at when is the f of x greater than 0, and we want to look at when is f of x less than 0, and we want to look at when is f of x equal to 0. Let's start with equal 0. Now remember, f of x is just also a fancy way of saying the y values. So remember, that's just the y values, right? So when we talk about equal to 0, when are the y values equal to 0? That would be when you're on the x-axis. That's when the y values are actually equal to 0. Well, when are the y values greater than 0? When they're above. The y values are bigger than 0 when they're above the x-axis, and the y values are less than 0 when they're below the x-axis. So we want to look at these different, and we want to describe when is the values. So let's look at the next example. So in problem number 2, when are the y values greater than 0? The y values are greater than 0 here. Notice this problem, the y values are greater than 0 up here. And the x values, when are the y values less than 0, right? When are the y values less than 0? That would be down here and down here. And then when are the y values equal to 0 is when they're actually on the x-axis. Okay, so let's stop a minute and let's go through the problems. Okay, so let's look at problem number 1, and let's answer these questions for problem number 1. When is f of x greater than 0? We want to know what are the actual x values when the y values are bigger than 0. So the y values are greater than 0 when they're above the x-axis. So we want to know what are the actual x values for that. So the x values are going to be out here, right? If you look at all of these ordered pairs and you say, what are the x values? When the y values are above 0, we say the x values are to the left of -3 or the x values are greater than -1. That's when f of x. That's when the y values are greater than 0. So the x values are to the left of -3 and to the right of -1. That will give you the y values bigger than 0. Now let's look at question B. Question B is saying, when is the function less than 0? When is the function or the y values less than 0? That would be below the x-axis. And we want to know what are their x values of x. So let's erase this. So the x values would be in between -1 and -3. So the numbers that are between, the x values that are between, will make the y values less than 0. So these are the x values that make the y value or the function less than 0. And then C is, when is the function equal to 0? And the function is equal to 0 when the graph is on the x-axis. So that would actually be the x-intercepts. So -3 and -1 is when the function is actually equal to 0, or the y values are equal to 0. So let's do it again, but let's look at it from questions 2 diagram. Okay, question 2. So now we're going to focus on graph number 2. So we want to know what are the x values where the function is greater than 0. So when is the function greater than 0? The function greater than 0 is when it's above the x-axis. And we want to know what are the actual x values that makes the function bigger than 0. So the x values are going to be in here. Like, just think about the ordered pairs that are in the yellow region. Isn't there x values in between -2 and +2? So -2 and +2 are the x values that makes the function itself greater than 0. Question B, when is the function less than 0? Or the y values, or the function, when is the function less than 0? Wouldn't that be below the x-axis? And so what are their x values? So the x values that correspond to when the function is below is going to be out here to the left of -2 and to the right of +2. So all the x values that are to the left of -2 or to the right of +2 is when the function or the y values is less than 0. And then when is the function equal to 0? The function is equal to 0 when it hits the x-axis. So -2 and +2 is when the function actually equals 0, or when the y values equal 0. Okay, so that's some new stuff. So now let's look at some review. To the new stuff, remember on the new stuff, we're looking at when is the function greater than 0 is when it's above the x-axis. When is it less than 0? When it's below the x-axis. And when is it equal to 0 is when it's on the x-axis. And then we can actually describe the x values for when that happens. We can describe the x values for when that happens. All right, so your homework is on this kind of stuff. Some new stuff and some vocabulary stuff. So here we have a question. And so part of chapter 2 is there's a lot of information and there's a lot of things, a lot of vocabulary that you guys have to know. So let's go through some questions and see how we do. So they want to know, what are the x values when the function is greater than 0? So again, what we just went over. So when is the function greater than 0 is when it's above the x-axis. And we want to know, what are the corresponding x values that go with when the function is greater than 0? So the x values are going to be out here. So the x values are at less than -2, or this looks like it's 1, 2, 3, 4 when the x values are greater than 4. Then we want to look at, what are the x values when the function is less than 0? The function is less than 0 when it's below, right? When it's below the y values are less than 0 when it's below the x-axis. And we want to know what are the x values that correspond with the function being below 0. So those x values would be in between -2 and +4. So when the x values are between -2 and +4, the function is below 0. And then when is the function equal to 0? The function is equal to 0 when it's on the x-axis. So that would be -2 and 4. -2 and 4 is when the function is actually equal to 0. And then what is the y-intercept? Isn't the y-intercept where it hits the y-axis? And it looks like that y-intercept is 0, -3. So just got to know a lot of vocabulary. Does the graph have a maximum or a minimum? And what is it? So isn't the vertex either going to be the maximum or the minimum? And isn't this the lowest the parabola goes? So we say it has a minimum. And the lowest it goes is -4.5. Right? That's the lowest it goes. When is the graph of f of x increasing? So let's erase. So when is the graph increasing? Well, remember, as you go through the parabola going from left to right and you're looking at the parabola, look at the y values, right? Each of these have an x and a y ordered pair. And if you notice, as I'm going through the ordered pairs, the y values are dropping or descending and decreasing, and then they reach the lowest point, and then the y values start to increase of the coordinates, right? Because each one of these has an x and a y, and we're focusing on just the y values. So on this side, they're increasing, and on this side, they're decreasing. So we would answer this question and say, when is it increasing? It's increasing to the right of the vertex, and so we have to say to the right of 1. So you actually have to say to the right of 1, don't say to the right of the axis of symmetry. Don't say to the right of the vertex, say to the right of 1. And when they're decreasing is when they're going down. So they're decreasing to the left of the vertex. And in this case, we have to put to the left of 1. We could have also said the x values are greater than 1 is when it's increasing, and the x values are to the left of 1 when it's decreasing. What are the x-intercepts? The x-intercepts are where the graph crosses the x-axis. So those are your x-intercepts. So the intercepts are 2 and -2 and 4. What is the equation of the axis of symmetry? Well, remember, the axis of symmetry always goes through, excuse me, the axis of symmetry always goes through the vertex. And the axis of symmetry is a vertical line, so you should write it as x equals, and then we should say x equals 1, because that's the x equals 1 line. So this is x equals 1. That's your axis of symmetry. Okay, let's go over a few more items. Okay, so you need to remember, if you haven't memorized these, you need to memorize the certain forms. We have vertex form, we have standard form, we have intercept form, and we need to know all of those different forms. You also need to know the vertex of each of those forms. So you should know in vertex form, it's just your HK. In standard form, it's the formula -b/2a. And for intercept form, the vertex is p plus q divided by 2. So those are things you have to memorize and know at all times. Look at problem number 1. Is problem number 1 in vertex form, standard form, or intercept form? Which form is number 1 in? If you said it was in vertex form, you are correct. And so what would the vertex be then, if it's in vertex form? Well, didn't it shift 2 to the right and 3 up, so isn't the vertex 2, 3? Isn't the parabola opening up? So if it's opening up, therefore don't we know it has a minimum, right? And then wouldn't the minimum be 3, right? So those are different things that you should know. Let's look at number 2. Number 2. Is number 2 in vertex form, standard form, or intercept form? Which form would you say it is? Maybe pause and think about it. Hit the stop button. Did you say it's in vertex form? Then you are correct. Did you say it was in standard form? Because you are also correct. It is in both forms. That one is both forms. Notice the A is 3, the B is 0, and the C is -5 in standard form. If I wanted to find the vertex, and I wanted to use standard form, I'd have to use -b over 2a to find the vertex. But why would we want to do that? We love vertex form, right? Isn't that the one we love? Because can't we just look at it and see what the vertex is? So while we know it's in standard form, we don't really have to go through all that work, right? Even though it is in standard form, 2, so it also is in standard form, but why not just say we know the vertex is 0, -5, because there's no shifting left or right, and our k is -5. We're going down 5, but there's no shift left or right, so our h is 0 in this problem. So it's 0, -5. Let's look at number 3. Number 3, is that in vertex form, standard form, or intercept form? Pause, stop the video, and answer the question. Did you say it was in vertex form? Because you are correct. Did you say it was in intercept form? Because you are correct. And you might go, well, why is it in intercept form? Well, couldn't I write this as y equals negative, and then isn't x plus 8 squared also mean x plus 8 and x plus 8? So isn't it technically in both forms, right? So, but again, we love vertex form because vertex form, you don't have to do really any math to find the vertex. So what would the vertex be in this case? Wouldn't it just be -8, 0, because isn't the k 0? So didn't it go left 8, and didn't it not go up or down at all? So isn't it -8, 0? And isn't my parabola opening down? And if my parabola is opening down, wouldn't there be a maximum? And in this case, wouldn't the maximum be 0? Let's look at numbers 4 and 5. In number 4, what form is that in? Vertex form, standard form, or intercept form? This is in intercept form only. And what's the p in this problem? -9. What's the q in this problem? +3, right? And then we'd have to use the p plus q divided by 2 to find the vertex. I'm not going to have you find the vertex right now. I just wanted you to identify what form it was in. Don't we also know that it's opening down because it has a reflection? So if it's the parabola is opening down, wouldn't we know this equation has a maximum? And then we'd have to actually find the vertex to be able to say what was the maximum. What about number 5? What form is that in? Vertex form, standard form, or intercept form? If you said intercept form, you are correct. It's only intercept form. And in this case, what's the p in this problem? The p would be 0, and the q would be 10, right? The p would be 0, and the q would be 10. So I just wanted to take some time to go over some vocabulary and make sure you guys are not just doing your homework, but that you're practice memorizing some of your vocabulary. And we'll go back.